Updates for you tonight. Crews are responding right now to a new fire start tonight in Yellowstone National Park. The ash fire.
The ground beneath Yellowstone has been far from quiet. Over the past several days, officials monitoring the park have confirmed that hundreds of small earthquakes have rippled through the vast volcanic region. These tremors, ranging from faint shakes barely perceptible to sensitive instruments to more distinct jolts, are part of a swarm that has gripped the attention of geologists and the public alike. The swarm is unfolding within one of the most geologically fascinating and closely watched areas on Earth, a place where the beauty of nature is intertwined with the restless forces deep below. Before we start, smash the like and subscribe buttons for more updates. Yellowstone's volcanic system is unlike most others in the world. Sitting atop a massive hotspot, the park's landscape is shaped by ancient eruptions, geothermal activity, and the continuous shifting of the Earth's crust. Steam vents hiss, geysers erupt with clockwork regularity, and mineral-rich pools shimmer in colors born of heat-loving microbes. All of this is fueled by magma reservoirs miles beneath the surface. Reservoirs that expand, contract, and shift over time. Earthquake swarms in this setting are not uncommon, yet the scale of the current activity has made it noteworthy. The number of tremors, combined with their distribution across the region, paints a picture of dynamic processes at work. These swarms typically occur when magma, hot water, or gases move through fractures in the rock, creating stress that is released as earthquakes. In Yellowstone, that movement can be caused by a variety of factors, sometimes linked to deeper magmatic processes, other times to shifting hydrothermal fluids. The recent swarm appears to be concentrated near known fault lines within the park, suggesting that stress along these faults is being relieved in bursts rather than in a single large movement. Each jolt is a small reminder that the forces beneath Yellowstone are in constant motion, adjusting, breaking, and reforming the subterranean architecture of the park. For scientists, every earthquake in Yellowstone is a data point that helps refine their understanding of the system. Instruments placed across the park detect and record seismic waves, allowing researchers to pinpoint the depth, location, and strength of each tremor. The current swarm has provided a flood of new information to analyze. By studying patterns in the quakes, whether they cluster tightly or spread over a wider area, whether they occur at shallow or deeper depths, geologists can gain insights into the movement of fluids and rock within the volcanic system. The swarm's ongoing nature offers a rare chance to observe changes in real time as the Earth's crust responds to forces far below. From a purely geological perspective, swarms like this are valuable windows into a hidden world. Yellowstone is not only a national treasure but also a natural laboratory for studying the life cycle of large volcanic systems. The park has experienced 3 massive eruptions in the distant past, events that reshaped continents and altered global climates. Since then, countless smaller episodes of activity have occurred, from lava flows to hydrothermal explosions. Earthquake swarms are one of the clearest signals that the system is alive and evolving. The current burst of activity underscores the idea that this landscape, for all its tranquility on the surface, rests atop a restless and powerful foundation. The location of these quakes matters greatly. Yellowstone's underground world is crisscrossed with faults, fractures, and conduits for fluids and magma. A swarm concentrated in one area can indicate localized changes, perhaps the shifting of superheated water reservoirs or the gradual intrusion of magma into new spaces. The pattern of the current quakes, spread across a section of the park but with clusters in certain zones, has sparked deep interest among monitoring teams. Such patterns can change over time, and watching these shifts unfold is key to understanding what forces are at play. Part of the fascination with this swarm comes from its timing and intensity. Hundreds of earthquakes over a relatively short period create a sense of urgency for observation and interpretation. This is not because each quake poses a direct threat to visitors, most are too small to cause damage, but because together they represent a living snapshot of Yellowstone's internal dynamics. For scientists, it is akin to catching a rare weather pattern on radar, a fleeting phenomenon that, if studied closely, can reveal deep truths about the system as a whole. The park's monitoring network is one of the most advanced in the world for a volcanic region. Seismometers, GPS stations, and thermal sensors constantly feed data to teams of experts who watch for signs of unusual movement or changes in heat flow. During swarms, These instruments record a dense sequence of events that can be plotted and analyzed. The recent swarm has generated vast datasets, capturing the precise timing of each tremor, the subtle shifts in ground position, and even minute variations in geothermal features. Over time, these records will help refine predictive models and improve the understanding of how Yellowstone responds to internal and external stresses. On the surface, life in Yellowstone goes on much as usual. Tourists marvel at the geysers, wildlife roams the valleys, and the rivers and lakes reflect the sky in serene beauty. Beneath that surface, however, the crust is alive with movement. The swarm serves as a reminder that Yellowstone is not a static monument, but a dynamic, ever-changing environment. It is a place where forces measured in tons of pressure and miles of molten rock continually sculpt the land, even if those changes are too slow or too deep to see directly. Historically, swarms like this have been recorded many times in Yellowstone. Some have lasted days, others weeks, or even months. Each one is unique in its size, duration, and characteristics. By comparing the current swarm to past events, scientists can begin to identify patterns and possible cycles. The similarities and differences between swarms can help determine whether the underlying cause is tectonic, hydrothermal, or magmatic. In some cases, swarms occur in conjunction with other signs, such as changes in geyser activity or ground deformation. Observing whether those factors are present now is part of the ongoing investigative process. One of the remarkable things about Yellowstone's seismic activity is the speed at which it can change. A quiet period can be followed by sudden bursts of tremors, which may intensify or taper off unpredictably. This variability challenges scientists to adapt their models and remain vigilant. The recent swarm exemplifies this unpredictability, with bursts of more frequent quakes punctuating periods of relative calm. The swarm's behavior is being tracked hour by hour, as even small deviations could indicate changes in the system below. The origin of these tremors lies in the physical properties of the Earth's crust and mantle beneath Yellowstone. The hotspot driving the park's geothermal wonders creates a zone of intense heat and partial melting. Magma here is not always in the form of large, liquid pools. Instead, much of it may exist as a partially molten, crystal-rich mush that behaves differently from a fully liquid magma body. Movements within this zone, whether due to changes in pressure, temperature, or water content, can create stresses that propagate upward, triggering earthquakes in the brittle crust above. The recent swarm likely reflects some such adjustment, with energy released in a rapid sequence of small slips along faults. From a broader geological standpoint, the current activity fits into the long-term story of Yellowstone's evolution. The park's volcanic history is marked by cycles of dormancy and renewal, with each phase leaving its mark on the landscape. Even when no eruptions occur, the constant movement of magma and hydrothermal fluids slowly alters the subsurface architecture. Earthquake swarms are one of the most visible signs of these deeper processes at work. They are both a symptom and a tool, revealing the presence of forces that would otherwise remain hidden from view. The scale of this swarm, hundreds of quakes, highlights the importance of Yellowstone as a focal point for geological research. Nowhere else combines such intense volcanic potential with such comprehensive monitoring. This allows scientists not only to respond to activity as it happens, but also to build a nuanced, long-term record of the park's behavior. That record, in turn, becomes a valuable reference for understanding other volcanic systems around the world. Lessons learned from Yellowstone swarms can inform how researchers interpret similar events in places as diverse as Iceland, New Zealand, or the Aleutian Islands. In the midst of all this, the park's geothermal features remain a source of fascination and a reminder of the forces at play. Hot springs continue to bubble, geysers erupt on their own schedules, and fumaroles release plumes of steam into the crisp air. These surface features are directly tied to the same heat and pressure that generate earthquake swarms. The movement of water and steam underground is a constant process, one that sometimes becomes turbulent enough to register as seismic events. The current swarm, though focused on tectonic adjustments, is part of that larger system of heat transfer and energy release. Scientists emphasize that swarms like this are part of Yellowstone's natural rhythm. The park's history is full of them, and they often occur without any significant surface changes. Yet their importance lies in what they can teach us about the state of the system at any given time. The patterns of these quakes, their depths, and their locations all add pieces to the puzzle. The current swarm is being scrutinized from every angle, with experts parsing the data for hints about shifts in pressure, the movement of magma, or changes in hydrothermal circulation. The global interest in Yellowstone's seismic activity reflects both scientific curiosity and the park's place in the public imagination. Few places capture the sense of Earth as a living planet quite like this one. The combination of stunning natural beauty and underlying geological power makes every tremor here resonate more deeply. The knowledge that the ground is in constant motion adds a layer of awe to the sight of Old Faithful erupting, or the grand prismatic springs shimmering in the sunlight. The current swarm reinforces that sense of connection between what is seen and what is hidden below. From the perspective of park management, such events are also a reminder of the need for preparedness and communication. Monitoring teams coordinate closely with researchers and agencies to ensure that any changes in activity are understood and, if necessary, shared with the public. The wealth of instruments in place means that even subtle shifts are detected quickly. This real-time awareness is essential in a landscape where the forces at work operate on scales both vast and unpredictable. For visitors, the swarm may be invisible unless they happen to feel a small tremor underfoot. Yet, knowing that the ground is alive with motion adds a certain thrill to the experience of being in Yellowstone. It transforms the landscape from a static backdrop into a dynamic participant in its own story. Every ridge, every geyser basin, every steaming vent is part of a system that is always in flux, shaped by the same forces that are now producing hundreds of tiny earthquakes. Geologically, the recent swarm may be seen as a reminder of the interconnectedness of Earth's systems. The movement of magma influences the flow of groundwater. The shifting of faults can alter the patterns of geothermal activity, and changes deep underground can eventually shape the surface in ways both subtle and dramatic. The hundreds of quakes recorded in recent days are threads in this vast tapestry of interactions, each one a small but significant marker of change. The study of such swarms also advances the broader science of volcanology and seismology. Yellowstone's current activity is providing a rich dataset that will be analyzed for years to come. By examining the seismic waveforms, researchers can refine their models of how energy moves through the crust here. By tracking the timing and location of quakes, they can better understand the triggers and sequences of swarm events. Each new swarm adds depth to the picture, making future interpretations more accurate. The magnitude of the swarm also prompts discussions about the thresholds and triggers for different types of activity. While most swarms pass without any surface disruption, they can sometimes be precursors to changes in geothermal features or, in rare cases, larger seismic events. Distinguishing between these possibilities is a central challenge for scientists. The current swarm, with its size and distribution, is a prime opportunity to study these distinctions in detail. Beneath the sweeping plateaus and winding rivers of Yellowstone, the Earth is engaged in a constant dialogue with itself, and the latest swarm of hundreds of earthquakes has added an especially animated chapter to that conversation. These tremors are not mere isolated jolts. They are the audible and measurable signs of a planet that is perpetually reshaping its own architecture. While they unfold invisibly to most eyes, their presence is as much a part of Yellowstone's identity as its geysers, wildlife, and towering peaks. The swarm is a kind of seismic heartbeat, revealing a rhythm that cannot be captured in still images or casual observation. The terrain above this restless underworld offers a stark contrast to what is happening below. Vast valleys stretch out under the high skies, forests ripple in the wind, and herds of bison graze across open plains. Yet beneath this calm surface, pressures are shifting in the brittle crust, and the ground is responding with hundreds of subtle cracks and adjustments. Each quake is part of a greater choreography, an ongoing negotiation between deep forces and the rock that holds them back. The sheer number of recent tremors suggests that something in that negotiation has tipped, releasing stored energy in a rapid sequence of microbursts. Seismic swarms of this scale highlight the complexity of Yellowstone's subsurface structure. Unlike a single large earthquake, which often stems from a straightforward fault slip, a swarm implies that multiple processes may be interacting at once. Fractures may be opening in several places, fluids may be moving through porous zones, and stresses may be transferring from one fault segment to another in a cascading effect. It is this web of interconnected reactions that makes such swarms fascinating and challenging to interpret. The rocks themselves bear silent witness to these changes. Layers of ancient lava flows, volcanic ash, and sediment record past upheavals in their composition and structure. As the recent swarm sends vibrations through these layers, scientists can detect how different rock types respond to stress and how existing fractures are reactivated. These subtle shifts in the subsurface can influence how future seismic energy is distributed, making each swarm not just a product of past events, but a factor shaping what will happen next. In the context of Yellowstone's deep history, the current burst of seismic activity is a fleeting event, measured against a backdrop of millions of years of volcanic evolution. The park's supervolcano has cycled through periods of immense eruption, slower lava flows, and long phases of relative quiet. During those quieter intervals, it is events like this swarm that remind us the system is never truly still. They are the tremors of a giant sleeping but restless, adjusting to the slow, inexorable movements of molten rock and pressurized fluids far below. The human relationship with this restless ground has always been shaped by observation and interpretation. Indigenous peoples knew Yellowstone's thermal features and dynamic earth as part of a living spiritual landscape. In modern times, the focus has shifted to scientific monitoring and understanding, yet the sense of respect for the forces at work remains. Every swarm of earthquakes renews that awareness, reminding both locals and visitors that the ground underfoot is part of a vast active system. While these quakes are too small to alter the skyline or change the course of rivers, they subtly affect the hidden plumbing of the park. Yellowstone's geothermal features, its geysers, hot springs, and fumaroles, are linked to networks of underground water channels. These channels can be influenced by seismic events which shift pathways, alter pressures, and sometimes trigger changes in timing or intensity of eruptions. The current swarm, by sending waves of energy through the crust, may be rearranging these delicate pathways in ways that are imperceptible now, but could later become apparent in the behavior of surface features. It is worth considering the journey of a seismic wave as it travels through Yellowstone during a swarm. A sudden slip along a fracture releases energy that radiates outward in all directions, shaking rock, water, and gas along its path. Sensitive instruments capture these waves and translate them into data, allowing scientists to reconstruct the exact moment and location of the quake. With hundreds of such events happening in quick succession, the resulting data set becomes a rich, layered record of how energy moves through this unique environment. This constant gathering of data transforms the swarm from a simple tally of tremors into a narrative of shifting forces. By examining changes in quake locations, depths, and magnitudes over time, researchers can piece together a story of cause and effect. They may see quakes migrating along a fault line, or deepening toward a magma-rich zone, or clustering near hydrothermal hotspots. Each pattern offers clues about what is driving the swarm, whether it be tectonic stress, magmatic movement, or hydrothermal pressure fluctuations. The diversity of the quakes in this swarm is also notable. While many are so small that they register only on instruments, others are strong enough to be felt by a keen observer standing in just the right place. These differences are not random. They reflect variations in the amount of energy released, the rigidity of the rock, and the presence of fluids. Small quakes may indicate microfracturing or minor adjustments, while slightly larger ones could suggest more significant shifts in the subsurface framework. Even without causing visible changes at the surface, swarms can influence the broader landscape over long timescales. The repeated fracturing and shifting of rock gradually modifies fault systems, creating new pathways for fluids and gases. Over centuries, this ongoing reshaping plays a role in how the geothermal and volcanic systems evolve. The current swarm is another step in that incremental process, invisible in its immediate effects, but significant in the long arc of Yellowstone's geological life. There is a certain paradox in Yellowstone's swarms. They are both common and unique. Common in the sense that they have occurred many times before, yet unique in their precise characteristics and the specific moment in which they unfold. No two swarms are exactly alike because the conditions underground are never identical. This means that each one adds something new to the scientific record, a fresh piece of information about a system that is too vast and complex to fully grasp at once. The setting of this swarm is as compelling as the swarm itself. Yellowstone's caldera, formed in the wake of one of the largest eruptions in Earth's history, is a vast depression ringed by mountains and filled with an astonishing variety of life. The same geological forces that created this landscape are the ones responsible for the tremors now coursing through it. To walk along the boardwalks near a steaming pool, or to gaze out over a broad valley is to stand above the very forces now expressing themselves in hundreds of tiny bursts beneath the surface. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on hundreds of earthquakes in Yellowstone?